So in this case, we are going to consider as a continuation from the previous part that we had working with the determination of the values of x, which affects the given functions or the given graphs, and that is supposed to be done graphically. The condition that we are going to consider in this class is that we can have f of x being equal to gx, whatever function that we are given, meaning to say there are two of them compared, where it can be equal to each other, or we can have one greater than, or we can have it less than the other one. How can we compare? How can we take our x values in such typical questions? The first one, it is something that is direct. We had this part in our grade 11, remember? When you were given two equations, y is equal to 2x plus 1, y is equal to x squared plus 5x plus 6, whatever that you're given. And from there, you are being asked to solve for x and y. All right? You were to solve for x and y. And what were you doing? We are simply equating these two because they are representing the same y that say it is equal. So also these two must be equal. As y and y, they are equal. And you equated this, which was a condition of finding the points of intersection. Finding of what? Points of intersection. So you take those now, x values, from what you are to solve. So in our case, we are no longer going through that process of solving because this is done graphically. So it simply means whenever this is to happen, what is important is the point or the point of intersection. For f of x to be equal to gx, this is happening, or the x values that we need are the x values at the point of intersection, which means that is our critical values are the x values at the points of intersection, or at the point of what? Intersection. What we have at the point of intersection. Those are our critical values this time. In the previous case, remember when we were dealing with f of x greater than 0, said our critical values would be what? The x-intercepts. This time, it is what? Intersection. The x values at the point of intersection. So whenever there's a comparison, whether it is going to be greater than, whether it's going to be less than, what we are doing there, or the comparison is done from the critical values, points of intersection. So what it simply means is that if I'm given two functions, because you'll be given this from the graph, remember this is to be done graphically. So let's say I have got our f of x, something like this. All right, this is our f. And what we have is also a linear, which is a straight line, all right, to represent another graph, all right, something like this. And let us call it g of x, which is what? The straight line. With these two graphs, if I am to determine the values of x, for which f of x is equal to gx, I'm supposed to work with the critical values, which are the x values at the point of intersection. The intersection at this point and this one. These are the intersection. So you need the x value to say what are the x values there. If we have got, let's say, -4 and this point is 3, the x values -4 and what? And 3. So meaning to say, for our f of x to be equal to gx, at the point of intersection, x is supposed to be equal to what? -4, or x is supposed to be exactly equal to 3. Point of intersection. Here it is a coincidence that the point of intersection is also an x-intercept. It is not that we are focused with the x-intercept, no. It is not about the x-intercepts. It's about points of intersection. It's just a coincidence, but this is what we have. This is your comparison. So since they say it is equal, you take direct x is equal to this, x is equal. It is equal to that, exactly equal to the given value. But now, when we are given this now as a comparison to say our f of x is now compared to gx, f of x can be less than gx, or it can be less than or equal to that, or we can have our f of x greater than gx. We can have any one of that. When it is a comparison like that, we must consider to say that this function that we are saying f of x, all right, let's start with that one, because here we said for each part, as long you are making a comparison of the two, whether it is an equation or an inequality, the critical values are what? The x values at the points of intersection. So we are still working with these values, -4 and what? And 3. But I want us to consider the first one, or the first condition. When we say f of x is less than the g of x like this, that means the values compared to this one, it does not mean it is a negative, no. It means in terms of its values, the y values are less than those y values for what? For g. So in actual sense, on the graphical presentation, f of x is found below gx. It is below the graph of gx. And by the way, this presentation simply means, or can be written as, gx is greater than f of x. So here, this same presentation, it simply means gx. As we can see, gx is pointing f of x. It is pointing f of x. So it means gx is greater than what? F of x. So compared in this manner, gx compared to f of x, we are simply saying the g of x is on top of f of x. Thus, f of x is below gx. This is what it simply means. So where we're going to have the solutions, all right, for this type of a question, all right, whether we are saying f of x is less than, or we are saying gx is greater than f of x, all right. This is it. We have got two graphs, and we remember our critical values, like I said, the what? Points of intersection at -4 and at what? At 3. So if we compare, we have got 3 regions that we are going to use. The first region, this one, values that are less than what? -4. The second region in between -4 and 4. and the third one, minus 4 and 3 in between, and the other one from 3, the point of intersection, 3 going this side, that will be the third region to be considered. So if we are to consider that, if we are to consider what we are having in this case, where f of x is below gx, all right, this is our f of x. Let us consider that this way. This is our f of x. All right, this is our f of x. This is our f of x. We are comparing it to what? To gx. We are comparing these two. From what? From the points of intersection at minus 4. From minus 4 going to the left. So let's consider as we are on the left side. What is happening on the left side? On the left side of minus 4, f of x, this is our f, guys, all right? It is on top of g. This is our g, the straight line. F is on top. From minus 4, it is, as you can see, it is found on top. This one is below. Not the x-axis. We are not comparing to the x-axis. No, we are comparing the two graphs. These two graphs. The other one is above, the other one is below. As we need where f of x is below. So this region is totally out. Also, if you want to take it, gx is greater than f of x. Gx is on top. Gx is not on top. Gx is below f of x in that region. So if we move on to the second region, from minus 4 to 3, the point of intersection, minus 4 to 3. This time we have got our f of x here. This is our f of x. This is our f of x up to here. It is below, it is under gx. Gx is on top. This gx is on top. This is the region exactly that we want, where f of x is below or where gx is on top of what? F of x. From minus 3 to, from minus 4 to 3. Moving on to 3, up 3, 4, 5, and so on. If we check, f is now on top. This is our f. It is found on top of g. We are comparing the two graphs, guys, to say which one is on top of the other. F is now on top. It is on top above of what? Of g. We do not want that because f is supposed to be below, or g is on top. So you can check g is what? G is below f. So we do not want that. So the exact region that gives us the solution where f of x is below gx is what? From minus 4 to 3. So therefore, in our solution, x must be greater than minus 4. But less than what? But less than 3. In between. Greater than minus 4, but less than 3. So if there was an equal to here, you're going to also put that equal to. But we do not have that one. So meaning to say our solution was going to be like this. So you find out that the regions that do not satisfy this condition satisfies another condition, which is the second one. So meaning to say, as of the second question, where they can ask us the condition of f of x being greater than gx, if it was like this now, where f of x, when it is greater than gx, we're simply saying f of x is what? On top of gx. Or it is the same way that can be written as gx is pointed here. We are saying gx is what? Less than. It can be in that manner. Gx is less than f of x. It simply means one and the same. Where gx is below, since we are saying it's less than, it's below what? F of x. The regions that failed here are the ones that satisfies this one now. Meaning to say this region of values that are less than minus 4 we can see that our f of x is above. It is on top of what? Of gx, which is exactly what we want. So these values that are going to the left, -5, -6, compared to the critical value, the point of intersection, -4, they are what to -4? They are less than. So therefore, in this condition, x is supposed to be less than what? -4. If there was an equal to here, you're going to also put that equal to there. All right? But since we also have another region here, from these three, the point of intersection, we saw that f is on top. So we are talking about 3 going up, 3, 4, 5, and so on. So that's another solution. X is greater than what? Greater than 3. So this will be the solutions now when it is given in that manner to say f of x is greater than what? Gx. It can be equal to, you also put the equal to there. What does not satisfy this satisfies the other region. So these solutions, remember we said we do not want them here, but they are needed when it is this type of a question. This is what you're going to write. So when answering a question, you must be very careful. Expect any. But as you can see, guys, it is just a direct comparison that you make from the what? Points of intersection. That is the critical values. Once you have got those critical values, you are done. I'm not going to waste much time on this type of a question. What we are going to do is to simply have another typical exam. This is a typical exam question that I'm going to give you guys here, where you are given, it was a graph, two graphs that actually were given, f and what, and g. So I'm just going to focus on the question. Do not worry about much about the information there. All right, so this is our f. All right, so here I'm going to indicate our f. That is our f of x. All right, then the g of x, this was it. All right, something like this. This was our g of x, like this. All right, so the question, after we're given a lot of questions to answer, but I'm just going to focus on question 6.3. It was actually from the March 2023 exam of the Gauteng province, March 2023. All right, so on this question, they want us to determine the values or the value of values of x, where x is to be taken from minus infinity up to 0. So take note here, they gave us an instruction. You must also consider that instruction from minus infinity up to 0. It means our values, they cannot be greater than 0. They cannot be greater than 0. Minus infinity, we talk about on the left side. All right, like this, up to what? Up to 0. So our values are only to be taken in that interval. All right, from 0 going this side. We're not going to take anything from 0 to that side. Meaning to say, as part of the diagram, from 0 to infinite, from 0 up to infinite, it becomes useless. This whole side of the y-axis, this is a y-axis. So as we compare this side, the right side here, it becomes useless. All this, it becomes useless. All this, it becomes useless because of the instruction that you are given here. The instruction is what is important here. The instruction. X is to be taken from minus infinity up to 0. So meaning to say from 0 going to the other side, it is useless. Which will be what? Gx is less than or equal to f of x. Gx, remember g is this one. This is our g. And this is our what? This is our f. So they are saying gx is less than or equal to what? Less than or equal to f of x. We are comparing two graphs. So when it is less than like this, it means it is below. Gx is found below what? Below f of x. So where is that g below f of x? All right, we said whenever you're comparing, you work with what? The critical values, which are the x values at the point of intersection. So for the point of intersection, we have got A, this one. A is the intersection and B. But you're not going to focus on B because B is on the what? On the right side, according to the question. So you're not going to focus on there. You're just going to focus on what? On A. So this is where our critical value is. At point A, where X is what? -1. Remember, I talk about the value of X. So X there is what? -1. So let's compare. On the left side of -1, all right? On the left side of -1, our critical value, what is happening? We can see that F is on top. This is F. F is on top of what? Of GX, meaning say GX is below. F is the one that is having bigger values of Y. Remember, I talk about the Y values. At this point, let's just consider we put a straight line like this, a vertical line. The value of Y here and the value of Y. The value of Y here is less than the value of Y that you're comparing to. Say maybe Y there will be 7, maybe Y there is what? Is 3. This is what I'm just trying to say. So GX is below in that interval or in that region. All right. So from -1 going to the left side, we can see that the G of X is below. This is exactly what we want. If we move on from -1 to 0 is another region. Remember, we are limited up to 0, up to 0 here. So from -1 to 0, if you check, your G of X is now above. This is your G of X. It is now found on top. If we check properly, this is our G. It is now found on top of what? On top of F of X. F of X is below. This is not what we want. Our condition is that GX must be below. So meaning to say, from that part that we are given of -1 up to 0, we're not going to consider that one. All right? We're not going to take that one. It opposes what we want. It is not part of our solution. This region that we are having here does not satisfy because GX is now on top of what? Is on top of F, which we do not want. All right? So meaning to say, in our case, the only solution that was going to satisfy this is that X must be less than what? We remember we're talking about -1 to the left. These values, they are less than what? -1. Because there is an equal to on our question, we must also have that one on our solution as well. This is it. Answer the question. So most of you guys, you do not answer the question. You do not read properly the question here. If this was not there, guys, take note. If this statement here is not there to say X must be taken from -infinity to 0, if that statement was not there, our solutions were not going to end there, because we can see that also here, if we were to consider the left hand side, if we check from that at B, we can see that F is what? On top. G is what? G is below, which is also the region that we want. From that X value, X is greater than the value of X at what? At B. It was going to be part of our solution, but because they said these values of X which are on this side, they are not to be taken, they mentioned it here. They mentioned it there. So meaning to say, we're not going to consider the right side of our functions. We're just going to consider to the left side from -infinity to 0. That is how you answer these questions. So let's revise, guys, as many questions as we can learn to answer the question in terms of your examinations. What is important is the understanding, not what you have done in class. In class, you have been taught about the textbook. Exam is exam. Read the mind of the examiner. Read to understand the question. All right? So that is it, guys. Where we do not understand or where we do have questions, let us communicate so that we can work on that one again. So that is it. Till we meet again.